Hello, students. This is your teacher, and we are going to look at Chapter 7, Lesson 1, which is called Writing Equations in One Variable. All right, so your green math books should be open to page 296. And we'll start with our learning target again. Welcome to Chapter 7 here. So, learning target today is I can read and translate a word problem into a mathematical equation. So we're going to be little translators today. So let's get our learning target in first. I can read and translate a word problem into a math equation. Whoops. Let's go back there. Okay, so this lesson is all about writing equations with one variable in them. So the first thing we'll do is kind of define what is an equation. The top of page 296, it has that highlighted word, equation. An equation is a mathematical sentence that uses an equal sign to show that two expressions are equal. So far in this year, we've been really focusing on expressions. Now we're shifting gears to equations. So equations are math sentences or a math sentence with an equal sign. So as soon as we knock the equal sign on an expression, it now is called an equation. And it shows, so we'll put this down here, it shows that two expressions are equal. That's what an equation does for us. So, for example, if we have the expressions that we've been kind of talking about earlier this year, something like this, 4 plus 8, that would be called an expression. And then how would we make that an equation? Well, we could put the 4 plus 8 and then knock an equal sign on it and then have a 12 on the other side. Now it's called an equation because it's got an equal sign. And then the next one, what if we had something like this? X plus 8. So we have a variable involved. If we did this, x plus 8 equals 12, it's now called an equation. So that's just helping us understand the difference between expressions and equations. So with that being said, we'll go ahead and get to example 1, where we're going to be writing equations based upon sentences that they give us or phrases that they give us. So here's example 1. The directions say, write the word sentence as an equation. So here's example A. The sentence says, the sum of a number n and 7 is 15. So we unfortunately do need to write out the entire sentence. The sum of a number and they have an n there, and 7 is 15. So they want us to take that sentence and make a math sentence out of it with symbols, words, not words, symbols, numbers, and letters. So first of all, let's take a look at this special word right here. Remember that the word sum represents addition. So we're going to be doing some adding here. And then we have a variable here that we're going to be using. We also have a number here that we're going to be using. Is an also important word. When you see the word is, I want you guys to start thinking about that that's going to be our equal sign. And then the number 15 is going to be important here. So we're going to be adding n and 7, and it's going to have to equal 15. So now we just have to write that down as a number sentence. So n plus 7 is 15. So the sum of a number and 7 is 15, is what we've just written there. The next one says, a number y decreased by 4 is 3. So let's write down the sentence. A number y decreased by 4 is 3. So let's start underlining or boxing in some important things here. So we have a number y, so we're going to be using y as our variable this time. Decreased by is an important phrase, so we're going to say decreased here. That's going to tell us things are going to be going down. And it says decreased by 4, so we know we're going to be using a 4. And remember, when you think of decreased, I want you to think of subtraction. Here's that word again, is. So is going to be like our equal sign. And then 3 is going to be on the other side of our equal sign. So now we have the important stuff. Let's just go ahead and write it out as a sentence. It says a number y decreased by 4 is 3. So if I have a y and it's decreased or subtracted with 4, it's going to equal 3. So a number y decreased by 4 is 3. Moving on to example C. This one says 12 times a number p equals 48. So let's write it down. 12 times a number p. And it actually says the word equals this time. So let's highlight the important things here. So we have a number here, so we're going to use 12. Then it says the word times. When we think of times, we're going to think of multiplication. 12 times a number p. P is going to be in there somewhere. This time it actually says equals instead of is, so we know that this is going to be our equal sign. And then it's going to equal 48. So if we have 12 times a number p, it would look like this. 12 times p, and then equals would be our equal sign, and 48. And we can actually simplify that, because remember, when you have a number and a letter, you don't actually need the multiplication symbol. So it would be the same thing as if we did this. 12p equals 48. So both of those would be correct. If you'd like to pause the video and go ahead and try that on your own at the bottom of 296, you can do that now. Okay, if you tried those on your own, so number 1 is translated into b minus 9 equals 2. And then on your own, number 2 would be 5g, or 5 times g, equals 30. Number 3 is going to be k plus 10 equals 24. And number 4 is going to be q divided by 4 equals 12. So now we're moving on to example 2. This one was only one part, and it's more of a real-life situation. The question says on the top of page 297, 10 servers decorate 25 tables for a wedding. Each table is decorated as shown. So if we look at the picture in the book, you can see how many candles are on top of the table. It says, let C be the total number of white and purple candles. Which equation can you use to find C? It's got 4 choices for us there, and if you look at the picture, you can see that there are 6 purple candles sitting there and 4 white candles. So that's in the equations and the choices they give us. That's where the 4 and the 6 are coming from. So let's jot down some important information they give us. They tell us that there's 25 tables that are decorated. And then next, based upon that picture, they're showing us that there are 4 white candles and 6 purple candles on each table. This is supposed to be a 6. All right. Then they also give us a variable. So they want C to represent the total number of candles. And that's on all of the tables, so not just one table. And they want us to write an equation. So here's the actual directions for the problem. And they want us to find C. So if they want us to find C, what happens is when we write an equation, the variable, the C, is going to become the first thing that we write down with an equal sign. So whatever they're trying to find, that comes first, and then we put our equal sign. So we've kind of taken care of this one step right here. C equals the total number of candles. So on the other side, I'm going to be using 25, 4, and 6, and some math symbols to figure out how I would actually figure out how many total candles. So if there's 25 tables, we're going to put a 25 down. And then if I have 4 candles and 6 candles on each table, if we add 4 plus 6, that's going to give us how many total candles on a table. So in parentheses over here, I'm going to put 4 plus 6. That's going to give us one table. If there are 25 of those things, the math symbol in between here is going to be a multiplication sign. So we would have 25 tables times the 4 plus 6, which would give us 10. So this would be our final equation. Now, if you simplified that a little bit, if you wanted to, you don't actually have to write this multiplication symbol. Remember, because if a number and a parenthesis mark are smacked together, it still means multiply. So you could also write this out like this, and it would still equal the same thing. So there is our equation. Now, it doesn't actually ask us to solve the equation. It just asks us to figure out which equation it would look like. Okay, and then lastly, we have an example 3. So we'll get to that one. Another real life situation here for example 3. All right, this one says after 2 rounds, 24 students are eliminated from a spelling bee. There are 96 students remaining. Write an equation you can use to find the number of students that started the spelling bee. Now, in this particular question, it doesn't actually give us a variable to use. So we get to choose the variable when that happens. So the first thing let's write down is what we're talking about here. We're talking about a spelling bee. And then some important information they give us about the spelling bee. They say that 24 students are eliminated after 2 rounds. So 24 students are eliminated. Then it also tells us that 96 students remain. And they want us to write an equation for how many students started. They don't actually give us a variable here that they want us to use. So we need to figure out what variable do we want to use to represent this right here, how many students started the spelling bee. Well, if you look in here, there's a S for students and an S for started. So I would like to use an S. So we're going to use an S, and the S is going to stand for how many students started. So now we've defined our variable. That's what the S stands for. So if that's what we're trying to find, just like our last example, we're going to start with the S. So how many students started? We're going to now use something with our 24, and we're going to do something with the 96 to figure out how many started. It said that 24 students were eliminated and 96 students remain. So if there are 96 students left and 24 students were eliminated, well, 24 and 96, oops, that should be a 96, not a 24. 96 remain and 24 were eliminated. If I add those two numbers together, I should end up with what was started with. So if I just put a plus sign here and I did that, that's going to give me how much started. So 96, which are remaining, plus 24, which is what we eliminated, would get us how many students started. You could actually rewrite this in a different way if you wanted to. What if we started with 96 in the front? So 96 students are what remain. If we kind of rearranged this equation, you could take the number of students that started and subtract 24, and you would end up getting 96 as well. So there's multiple ways of writing equations when it comes to these kinds of questions. So some of these, if you do on an example or on a test or on an assignment, there could be multiple answers. And that brings us to the last example for the lesson. So if you want to pause and try 5, 6, and 7 on your own at the bottom of 297, you can go ahead and do that now. All right, for number 5, your equation should be x minus 7 equals 10. And then number 6, 28 plus x equals 52. And then number 7, 24,000 equals 24 times x, and that times 60. And of course, in those ones, it doesn't tell you what kind of variable to use, so I'm saying x as any variable. You could have used any letter there. Okay, and that brings us to the end of our first lesson of Chapter 7.